As California adds more renewables, such as wind and solar power to its grid, and more electric cars to its streets, the potential benefits of energy storage is getting more attention. That's why PG&E is conducting energy storage pilot projects near Vacaville and in San Jose. And the storage devices are batteries, lots and lots of batteries. Some in the industry call energy storage the Holy Grail, because if it works, and if it becomes economically feasible, then it can prevent new power plants from being built and can smooth the sometimes erratic supply of power from renewables such as wind and solar. And the utility industry is watching PG&E's efforts. PG&E is working with the state's grid operator, as well as with the California Energy Commission and an industry research group on the project. Quite simply, batteries can be charged when demand is low, and then that reserve power can be sent to the grid when demand grows. PG&E's John Eric Tallman talked about the technology at the site of the San Jose project.
It's a storage device. You have to charge it at some point of the day, and then you can discharge it at an opportune time. So we would look at charging the device off-peak during the night when the feeder is unloaded by the rest of the customers, and then during peak periods or when load is high and voltages might have some difficulties to discharge the battery.
In San Jose, at the end of a line that feeds electricity to Hitachi Global Storage Technologies, 4 megawatts of batteries are being installed. In Vacaville, 2 megawatts of high-energy sodium-sulfur batteries are now in place at a PG&E substation.
This is a relatively new technology. It's still being tested, not only here in California with PG&E. It's being tested in a few other places, but different utilities have different duty cycles and different load cycles. And utilities across the country need to get reliable and credible information regarding how this battery and this technology can actually work in the real world rather than just in a simulated or computer simulated world. So this project is very important.
Although the industry is confident that such projects will work, questions remain about their economic viability and how well regulators and utilities will be able to deal with power sources that serve as both generators and as storage devices.
Before a utility is going to invest widely in any new technology, you have to get a sense of how does it work? And so a big part of this project is understanding, all right, what can this do? And then after what can this do, does this do it more effectively than other possible solutions? And so I think that's the big question.
Battery storage is just one of the ways that energy can be stored. PG&E's massive Helms hydroelectric facility in the Sierra Nevada mountains is another good example. Helms uses the elevation between 2 reservoirs to make and release power depending upon energy demand.
So there's a lot of things changing in California with how we use energy. We've got photovoltaics and prices coming down on that. We're using more wind. Our customers are looking at better uses of their energy. They're more conscious about their environmental footprint. We're looking at the advent of electric vehicles. All of these things are drawing us to use and distribute energy in a different manner. The ability to store energy can help in that new world.
For Currents, I'm Matt Nauman.